Everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to finish up chapter number 11. We are on lesson 6. That's found on page 540. Page 540, you're going to find binomial distribution. I guess you could kind of think maybe back to last chapter where we were talking about binomials and remember the Dorito and all that stuff that we talked about back there, Pascal's triangle. We're going to be incorporating some of that into this lesson, talking about how to use combinations and different things in our probability here. All right, so let's go ahead and look at page 540. I've got down here on the screen, the binomial distribution are events that have only two possible outcomes. That makes sense, right? Because binomial means two nomials, two terms, two events, okay? And so it's the only two possible outcomes, success and failure. That's it. Nothing else. You know, there's not like three different things. I could get a red, I could get a blue, I could get a green, okay? It's just two, either yes or no. Did it work? Yes. Did it not work? No. Okay. Did it succeed? Okay. Did it fail? Those are the only two options. What are the properties of binomial distributions? Well, number one is basically what I just told you. Each trial has only two outcomes. If that's not true, then it's not a binomial distribution. The second one is that each trial is independent. Again, if that's not true, it's not a binomial distribution. So what does that mean? If the trials are dependent on something else, if there's more than one thing in play, then it's not binomial distribution. Number three, there is a fixed number of trials. You can't have an indefinite binomial distribution. For example, I can't say, well, how many times, if I flip a coin in the air, how many times will it land on heads and how many times will it land on tails? Well, there's only two options. It's only heads or tails, so that works. Each trial is independent, so that works. But there's not a fixed number of trials. You have to say out of 10 chances or out of 20 chances. You have to put a limit on it. And the third property of a binomial distribution is the probability of success is constant in every trial. In other words, you can't switch and change whether or not it's actually going to happen or not. You can't have a higher percentage or a lower percentage. It has to remain constant. And it doesn't have to be 50-50. Not like a coin, you flip a coin in the air and it's always 50-50. It's either heads or tails. I mean, you could have it as long as it's always a 10% chance. Okay, so let's say you have one of those spinners that we were talking about. So I have a spinner. Well, if this is the number 1 and this is the number not 1. You like that? Okay, so those are the choices. It can either land on the number 1 or it can land on the number not 1. Well, 1 is only 10%. And not 1 is 90%. But if it remains constant the whole time, then this can be a binomial distribution. So it doesn't have to be 50-50, but it does have to remain true. It can't change. You can't have one that is that and then one that's that, one that's 50-50. You can't go from 10% to 50-50. It has to remain constant for every trial. All right, let's determine if this experiment is a binomial distribution or if it is not a binomial distribution. And look on page 541, you'll see this. So what we're going to do is we're going to talk about this, and then we're going to go through all 4 of those properties, and you're going to answer yes or no, is this a binomial distribution? So number 1, a coin flipped 5 times where the number of heads is counted and recorded. So does it pass number 1? Each trial has 2 outcomes. Yes, it does. It passes number 1 because it's only heads or tails. All right, number 2, each trial is independent. Is that true? Yes, because we flip it, heads or tails. It's not dependent on the previous trial. It's not dependent on anything else. Each trial is an independent heads or tails. Okay, so it passes number 2. Number 3. There is a fixed number of trials. A coin is flipped 5 times. Yes, we decided that 5 times is the limit, and so there's a set amount of trials. Number 4, the probability of success is constant on every trial. So every time you flip the coin, it's a 50-50, and that never changes, okay? It's always heads or tails. Half the time it's going to land on heads, half the time it's going to land on tails. You can't change that. It is a constant. So is this one? Yes, this one is. Number 1 is a binomial distribution. Number 2. 2 friends, Adam and Bob, agreed to play a best-of-5 match of rock, paper, scissors, right? You know that game? Okay. And then, you cut the guy's paper or you crush his scissors with your rock. Okay, so they're playing that game. And the winner gets the last piece of pizza. I have played this game before, and I've played this game before for pizza, believe it or not. Maybe you have too. So, Adam and Bob are playing the game, and they want to eat the last piece of pizza. Is this a binomial distribution? All right, so go back up here. Does each trial have 2 outcomes? All right, well, think about that. Does each trial have 2 outcomes? Yeah, you might say yes, because Bob could win. Okay, Bob does scissors, and he cuts the paper, so Bob wins. Or Bob could lose. Bob puts scissors down, and Adam puts the rock down and crushes his scissors. However, there is another outcome, and that is the tie. What if they both put down scissors? Okay, then you got to do it again. And so the tie is one that makes this is not a binomial distribution. It only takes one of these to disqualify the whole thing. Okay, let's keep going down it just for something to do, just to kind of more practice on this. Is each trial independent? The answer would be yes there. Each trial is independent because every time you restart, it's independent. It doesn't depend on the last one. Is there a fixed number of trials? Technically, no. And you might say yes. They said it's a best of 5. But what about the ties? The ties are going to extend that. What if there's 5 ties? So now it's not really the best of 5. They actually played 10. And so that would be a no on that one because there is not a set fixed number of trials. Number 4, the probability of success is constant. And that I would say no as well. The book says yes. And I mean, I get what they're saying, but I would say no because of the whole tie thing. The probability is that there could be a tie, but what they're saying is the probability of putting scissors is 1 in 3. The probability of putting paper is 1 in 3. So I get that, but you could argue with that one. Okay. The last one, number 3. Is a construction company. This is on page 542. A construction company knows the weather is good 80% of the time. They want to calculate the probability that the weather will be good at least 4 of the 5 workdays. The first property, let's look at that. Each trial has only 2 outcomes. I'd say yes, because it's either a good weather day or it's a bad weather day. There's no okay weather days. At least they don't talk about that. I guess you could theoretically have an okay weather day. Maybe it was a little bit cold or a little bit hot or a little bit rainy that day or something. But in this case, we're looking at 2 outcomes. It's either a good weather day or it's a bad weather day. Okay. Number 2, each trial is independent. Well, not really, because you could have like a rain system move through, like for instance, a hurricane. Okay. If you're working in Florida, a weather pattern could come in and it could just sit there. You could have 5 straight days of rain because of weather patterns. And then randomly the weather pattern clears up and then you have 5 straight days of sunny days. So not really. Each day kind of has its own different chance. And this is to be seen when you watch the weather report, right? They say there's a 60% chance of rain this day and a 20% chance of rain this day. So every day is different. So I would say that would make this one a no-go right there. Let's look at number 3 real quick. Is there a fixed number of trials? Yes, 5 days. And the last one, the probability of success is constant on every trial. I guess I would say no, because again, kind of going back to the whole idea of the weather systems, that could ruin several days in a row. So that could change your probability on that. So I would say that that one is not a binomial. All right, let's look at our formula. Now, they dedicate 2 pages right here, page 542 at the bottom and 543, to kind of teaching you and showing you the way this formula is derived. Okay, they show you the derivation of this formula right here. I'm going to skip that, but if you want to, spend all the time that you like looking over the derivation of that formula, okay? This will show you how they get it, how they came up with what they got. But most of you probably don't have time for that. So you're like me and you just want to skip it. Go to page 544. Page 544. All right, so here we go. Probability x equals small x. The probability of successful outcomes uses this formula right here. This is what you have to know right over here. Okay? So the combination with n and x times the probability to the x times the q to the n minus x. All right, whoa, what is all that? Well, let's look at it. I've got them all written down right here. So what is the n? The n is the number of independent trials. Remember, you could have 5 independent trials, 7, 10, whatever, but you have to have a number. So that would go right there, and well, that's the only place. It technically goes there too, but that's you'll see in just a second what goes there. Next is the x. This is the desired number of successful outcomes. The x goes right there, the x goes right there, and technically the x goes right there. Next one is the number of failures. That's the n minus the x. That's this one right here, the n minus the x. The number of failures. So how do you get the number of failures? Well, you take the number of trials and you subtract the number of successful trials, and that's going to be the number of failures, because there's only 2 options. Remember, it's either success or failure. So you take the whole number, subtract out the successes, and that's going to give you your failures. And then you would take the p is the probability of success right there, that p. And then q is the probability of failure on a single trial. This is important right here, on a single trial. You're not talking about the whole thing. This is talking about the whole thing. You're talking with those pieces, you're talking about just single trials. Okay? Some of you are looking at that going, ooh, I don't know if I can do that. You can do it. Trust me, you can do it. We'll do it together. All right. Answer the questions given that the probability of a good weather day is 80%. So we're kind of going back to that whole idea of the good weather day. Well, what is the probability that there are exactly 4 days of good weather during a 5-day work week? So let's talk about what each thing is. What's the number of trials? How many days are we talking about? Okay, we're talking about 5 days. What's the number of successes? That's the x, right? And how many successes? What do they want? They want 4 days of good weather. So they want 4 successes. What's the probability of success for a single trial? Well, the way that you would do that is take this right here. The probability of good over total, so that'd be 4 over 5, and that's going to equal 0.8. Okay? So 0.8 is our probability of success, so that's our P, is 0.8. What is our probability of failure, which is our Q? That is 0.2, because remember, that has to equal 1, because there's a 100% chance of something. Either it's going to be successful or it's going to be a failure. All right, now we want to go ahead and write down our formula, and we're going to plug into the formula. So C with the N and the X, and then we have the probability of our to the x, and then we have the negative results to the n minus x. All right, so let's fill this in. What is the n? The n is 5. So C with a 5. And what is the x? It's a 4. This is going to be a combination right here. We'll get to that in just a second once we start working through it. And the P, the probability of the event, is going to be times 0.8 to the 4th, because that's the x. The x is the 4th. And then our Q is our 0.2. And that's going to be to the n minus the x. So that's going to be to the 5 minus the 4, or to the 1. All right, let's write out this combination right here. So the combination, if you remember how to do that, that's the n, so that's 5 exclamation over top of the r, which is 4 exclamation times the 5 minus the 4 exclamation. So that's this written out. And that's going to be times 0.8 to the 4th. We could actually do that right now if you want to. So let's go to our calculator and actually do that. 0.8 to the 4th. 0.8 to the 4th equals 0.4096. 0.4096. There you go. And then this one's pretty easy to solve because it's to the 1, so it's just 0.2 times 0.2. I think what I would do here is I would do this first, and then I would multiply it times 0.4096, and then times 0.2. All right, let's go ahead and do this on the calculator. This thing right here is going to cancel out because this is 5 minus 4, which is 1 exclamation. 1 times nothing, 1 times 1, whatever, is just 1. So that's going to cancel out. That's not that important. So basically we have 5 exclamation, 5 factorial is the way to say it. 5 exclamation point divided by 4 exclamation point, and that's going to equal 5. So 5 times our 0.4096 times 0.2 equals 0.4096. 0.4096. And that's interesting. Came out to the same thing, right? It just, it is what it is. That's your answer for that one. And you would round it to whatever place they tell you to round it off to. This one doesn't tell us, so we'll just leave it all the way out to the 4th. All right, this video is a little bit longer than I wanted. I'm not going to have time to do another one. The process is the same. You just kind of plug in. You can look at B right there. The process is the same. You would just plug in the different numbers, the new numbers. So if you have any questions, you can just go back and look at that one example that I did for you. Hope you learned something today. Hope you understood. If you didn't, slide it back there. Watch it again. Try that practice problem there, or go to the exercises and try some of those. Use this formula, plug into the formula, and then use your calculator to solve it out. Okay? All righty, we'll see you later. You have a good one. Bye-bye.